Welcome everyone to our webinar entitled The Edge Awakens, How Edge AI Will Redefine Business in 2026. This webinar is sponsored by OnLogic, Intel, and Automation.com, a subsidiary of the International Society of Automation. I am Renee Bassett, Chief Editor of Automation.com, and I will be your host for today's program. Industrial intelligence is moving to the edge where data is created and real-time decisions can drive significant return on investment. For today's discussion, we want to talk about the future of artificial intelligence at the edge and also what you can do today to make the most of it as quickly as possible tomorrow. But this isn't just a talk about trends. It's a chance to hear from and ask questions of experts from the companies developing the technology that will define business in the coming years. Today's technically focused discussion is designed for engineers and business leaders who are building the future of industrial automation, smart infrastructure, and robotics. Our speakers will share key predictions for Edge AI in 2026, including where the first billion-dollar efficiency gains will emerge and which overlooked use cases will quietly outpace the hype. Also, primary concerns of today's tech leaders, from cybersecurity to ROI clarity, and the purpose-built solutions that are addressing them. Other topics we'll cover include how edge and cloud will interlock as AI goes everywhere, and how to design a complete solution that is easy to work with and built for scalability. We gathered some real experts to join us today, and we want you to have a chance to ask questions. So this will be an interactive conversation, and you can use the questions icon on this interface to submit your questions at any time. They'll only be seen by our speakers, and we will get to as many as we can before the end of our hour. This presentation, including the Q&A session at the end, is being recorded, and afterward you'll be emailed a link for viewing it later on demand. Now, for some background on our distinguished speakers. James Floyd is currently the Director of Sales and Applications Engineering for OnLogic. With nearly 19 years of experience at OnLogic, James has a deep practical understanding of the hardware required to deploy complex computing solutions. In his current role, James leads the teams responsible for customer product strategy and applications engineering. Matthew Formica is with Intel. He is Senior Director and Head of Edge Product Marketing and AI PC and Edge AI Software Developer Relations. A seasoned technology executive and business strategist with more than 16 years at Intel Corporation, Matthew leads a global team driving go-to-market strategies for Intel's edge computing business and AI inferencing developer outreach across AI PC and Edge. Welcome, gentlemen. I'm very happy to have you here with me today.
Thanks, Renee. Great to be with you. James, great to be with you.
Likewise, Matthew.
To start off our discussion, some say that by 2026, Edge AI will be the quiet power source of global business. But we need some background before that. Matthew, would you please set the stage for us about where we are today concerning Edge AI?
Sure. Yeah, happy to get this conversation started and looking forward to our conversation as we go. You know, the Edge has been around for a long time, right? People have known it as IoT or embedded. It goes under different names, but it's really about computing out in the real world. Of course, there'll been factories and hospitals and retail stores, et cetera, in the real world for a long time. So the Edge is not new. More recently, over the last 10 years, we've seen the rise of Edge AI, which is really super focused on computer vision data, videos, images, and that's what's really powered the first wave of Edge AI, I would say. We've seen that, we've seen predictions that it's going to somehow like totally take over all of the Edge. It never quite does. Someone that an old mentor of mine once told me that the trends come later to the edge than you would expect, but then are more powerful at the edge than you would expect and continue longer. And I think that's true here. We see computer vision and edge AI keep growing over time. I would say, at least when I look at the business, it's not yet half of the workload. There's still a lot of pure edge workload that happens, and yet edge AI is coming on strong in that. And so it's kind of already here and not yet here. And so it's an interesting moment in time for the edge. James, what are your thoughts?
Yeah, absolutely right, Matthew. The edge has always been there. It's funny you mentioned IoT. When I interview people for sales engineer, I say, "What is IoT?" Right, and the idea is it's a buzzword. The reality is the idea of computing, not your traditional desktop or not your traditional data center, everything in between, and that exists everywhere, right? And so it is just kind of somewhat of a rebranding exercise, I guess, so to speak, as it relates to transitioning from IoT to the edge.
Excellent.
Absolutely.
Well, let's get us to then your first predictions about 2026. One of the things that I've heard is that generative AI is getting all the headlines these days, and that's what I think of when I first think of AI. But vision models are coming up and seem to be having a transformative impact. Would you say that is something that is going to be important in 2026?
I would, and that would be my first prediction for 2026, is that a new round of edge AI innovation is upon us, and a new inflection point with the introduction of Gen AI into edge AI. So what do I mean by that? And there's really a technology techie part of this, and then sort of an impact on business and solutions part of this. But if I just start with the technology point that's driving this, up until now, you've had, for the last 10 years, this focus on traditional computer vision. And you've seen use cases like license plate detection in smart cities, wrong way driving in smart cities, a variety of cars sort of use cases, worker safety and defect detection in factories, a certain amount of frictionless retail and self-checkout in retail solutions, variety of use cases unlocked by traditional computer vision. Those models are pretty small by latest comparison. If you think about traditional computer vision models, maybe something from the YOLO series for any of our viewers that are familiar with that, 50 million parameters or less in size. So it takes a certain amount of compute to run that. But now we have generative AI coming in, and we've probably all experienced it with an online chatbot or some sort of tool, very text heavy in that context. But there's this new innovation that's coming to the edge. These models have new versions that are being designed around vision, around computer vision data, which is the lifeblood of the edge. And they're called vision language models, or VLMs, or vision language action models, VLA. And they bring the power of generative AI to computer vision. And there's a lot of interesting properties of those models. They unlock a lot of capabilities because of their resiliency. James, when we talk to customers, it feels like maybe at least half of the customer conversations we have now are about this new wave. There's a lot of POCs being done. When I go to AI developer conferences, most of the research papers are focused in this area. What are you seeing?
Yeah, I want to step back. I guess I like to use the analogy of just even interpersonal communication amongst us, right? And I like to talk about the idea of, hey, phone call, you get limited data, right? You're essentially, it's akin to the LLMs, right? Where you're just getting text, right? Then you get on a video call, and now you have text, plus you have visual aids. And then you get into live person communication, where you're even getting more. And with each step along the way, it's more data, right? And so back to this prediction of the edge, for me, I look at, big part of the drive to the edge is with that growing need, that trend that's going to getting more context and more data. There's lots of data out there that's showing us that the infrastructure is not ready for that, right? We're already limited in terms of just text-based search going back to the data center and being able to get compute and coming back for your data. And so that just the infrastructure by itself, in my mind, of getting data back and forth is a limitation. But then you have, CEO of Microsoft just saying today that there's even limitations at the data center itself. So forget about getting it back and forth the data center. There's not enough compute there. So in my mind, those are two big reasons why we are going to see the edge really start taking off in 2026. It's born out of necessity, right? There's just, we are advancing the models. We're able to take in more data to do more accurate modeling and better AI, but we need to compute it somewhere. And again,
Yes.
if we can't compute it up in the cloud, we can't rely on the data centers. It needs to be done somewhere, and that's where the edge is obviously very exciting for us.
Yeah, and there's these new vision language models, VLMs, are an order of magnitude bigger than the traditional computer vision models, right? So you're going from a 50 million parameter model to 500 million parameter, 5 billion parameter model, or bigger. And you can run these at the edge, but they require more compute to get this done. And then you have to think, well, what are the benefits to the solution? Why would you go to something that requires more compute? One of the main reasons is resiliency in the model. The model has greater understanding of what's actually going on.
Accuracy.
And is more flexible when the environment changes or when the situation changes. So just think about traditional worker safety models. Are they wearing their protective gear? Are they wearing their hard hat? With a traditional computer vision model, if that safety gear changes too dramatically, the model can no longer identify it. The model breaks. It doesn't realize it's still safety gear. Whereas with these new VLMs, because they have again, to geek out for a moment, a transformer-based architecture from the Gen AI world, they actually are able to understand it's still worker safety gear. And so it keeps working, and your solution doesn't break even in the face of a greater amount of change in the real world. And so that ability to be resilient in the face of changing packaging, changing assembly line, changing information is what gets people really excited, because suddenly you can build solutions that are much more powerful for the real world. One of the biggest areas of innovation is in robotics. And Intel's been in robotics for a lot of decades. Traditionally, we've been in the controls side of the robot, which manages the pistons and actuators, and has sub-millisecond timing sometimes to make sure that robot stays safe. But increasingly, the AI side has been the focus with VLM and VLA models, because you need that additional understanding of the environment to have the robot be able to navigate the environment properly. And so whole new areas of functionality are emerging thanks to this new class of computer vision based Gen AI models at the edge.
Yep. And I guess I would just add, Matthew, that right from a robotics perspective, again, another use case that can't rely on the lag to the data center, right? That is another need for the local edge compute, because again, just you can't afford that delay in robotics. It's got to be as close to real time as possible.
Absolutely. And we're seeing that especially with some of the newer types of robots. But really all of them have that same factor. There's really three classes of robots that we see. One is the traditional static arm robots, kind of in one location, often in a factory. Then there's the new AMRs, autonomous mobile robots. Those are often seen in a warehouse, and they're moving packages around and so on. Those rely on having AI and computer vision to be able to see where they're going. But then the most flexible and the most exciting are humanoid robots form factors. To be frank, haven't seen a lot of deployment of those in the real world yet. They're really in the research labs, but they're pushing the envelope of what's possible with this new class of models, and showing the increased amount of compute necessary, all locally, to your point, to get the work done. And all of this increased compute and workload raises the interesting question, is it affordable?
It's a great segue, Matthew. Yeah, our next, for the next topic, Renee, I guess there's the second prediction that we would have is in 2026, shifting the conversation for how much will this cost me, traditionally considered as a return on investment, to how much will this cost me to deploy and operate over the next 10 years, which shifts the conversation to total cost of ownership, TCO. And so that is something that, again, back to this idea that the edge is not new. This is something that that we've seen forever, right? People have proven out in a conceptual form, a proof of concept to say, hey, in this lab environment, this is exactly what I want to take to production and deploy in mass. And the reality is, there's so many different considerations there. You can get away with a cheap, $200 computer in a lab, but will that account for your environmental considerations, right? Or conversely, cool, I threw a lot of compute with multiple GPUs on this and it runs flawlessly. Well, is that scalable? Because that's a very expensive solution, right? And so there are a lot of different considerations that organizations should be putting into account when they're thinking of total cost of ownership. And so first and foremost, the thing that we've run into for as long as I've been here is really the environmental considerations, right? A lot of these environments are going to be going in a manufacturing environment where dust and debris will kill a traditional fanned computer. And I take it for granted, this idea of fanless, but it's going to be a new concept for folks as they've gone away from, as they've used traditional servers or desktops, and now they're trying to think, what do I need to account for in an industrial environment? And getting to a solid state compute is your first best bet for a reliable solution that will stand the test of time. Additionally, for OnLogic, a lot of our solutions have been designed to be modular, right? Everyone needs something different, and our designs account for the various needs, whether it be CAN bus, multiple LAN, PoE. Everyone needs something different, and as a PC manufacturer, making it modular is extremely important. I'd also say for Intel specifically, right, this idea of evolving and simplifying the architecture. Intel's Core Ultra series with advanced GPUs and integrated NPUs really allow a more purpose-built solution that can scale for all customers.
Yeah, thanks for bringing that up. And often when we look at Edge AI specifically, there is sort of this default assumption that you need to throw a lot of expensive external accelerators and discrete GPUs onto that solution. While it makes a lot of sense in a training environment in the data center, for some of the reasons you mentioned, it doesn't work at the edge, right? You talked about fanless. Certainly, Intel has a complete portfolio of products at the edge, many of which don't require fans. And we have to deal with having SKUs for industrial use conditions, very hot, very cold, extended temperature, being able to run 24/7 for many years without failure. And those products require careful testing and design to meet those specifications. We are very excited by our Core Ultra series. We have our upcoming Core Ultra Series 3, codenamed Panther Lake, that people are very excited about. It's going to have a extended temp variant of it. We don't do that with every product on our roadmap, but we are doing that with that one. And we're excited because it has so much AI capability integrated right in. So you really don't need to have a discrete accelerator in many cases. A lot of developers and solution builders will use Intel's OpenVINO open source software for inferencing. If they're building for the edge, they'll use our OpenEdge platform open source stack out on GitHub, which gives you industry-specific suites for developing in different industries. Your Edge AI solution fully using Intel Core Ultra processors. And those processors, just to go back to the robotics example from earlier, allow you to do both the control side and the AI side all in one processor, which is an amazing innovation from an ROI perspective, because so many high-end robots today end up having to build in two separate products, one for controls, one for AI, different software stacks, complicating the overall board and system design when you could do it all much more cleanly with one product. And so we're particularly excited about that. And we do see ROI as one of the key sort of chasms to cross going from POC to production.
I guess, Matthew, a topic that we didn't really discuss yet is, back on, the end users and what they can do, right? We've been talking a lot about the hardware and how to optimize the hardware, but would you agree that there's a lot of opportunities to optimize and simplify on the model side as well?
There's a ton of opportunity there. These models start very big and then they get shrunk down. And we're increasingly seeing more and more cost-effective hardware be able to deliver the solution. When you get below certain tipping points, suddenly they start reaching scale deployment, because suddenly companies realize, oh, this actually saves 20, 30%, 2x, 3x over the way we were doing it before. And so it's sort of the less. There's some law about this. I'll forget the name of it now. That the cheaper technology gets, suddenly the more it gets adopted, and you actually get more usage of the technology because now it's cost effective enough to scale out
It's
a lot
accessible to
more.
everybody, right?
Yeah, and so I totally agree with you on that point. One interesting use case that's getting a lot of excitement from some of our customers in this area is order accuracy checking in retail stores. So there's a lot of times when you order takeout and you get your order by some delivery person, your dinner, and they've had to make sure that if you ordered some food, that the right utensils got into the package, and if you ordered a soda, that brand of soda made it in, and so on. There are now computer vision systems being designed that will point a camera at the worker who's assembling all the pieces, because if you're doing a lot of those, you might forget something. And so the system can look at the invoice and look at what got actually put in the bag and flag, oh, nope, these don't quite match. And that makes that process so much more efficient than having to send a second order out because you got it wrong the first time, or having a complaint from the customer and then they don't come back again. And so those solutions, while there's some upfront cost in implementing and installing them, end up saving so much in real world usage. And the great thing, again, to tie back to the technology story, that's this new inflection point that we talked about earlier, is when the packaging changes on the soda or what have you, you don't want the model to break and suddenly the solution stops working. So you need a VLM model that can keep track of the fact, that they put a different sports team on the soda, but it's still a can of soda. So yep, can of soda made it into the package, into the bag. And so those are the kind of things that these new models can handle that some of the old models couldn't. And some of the cost savings that emerge from implementing solutions like this.
We've been talking a lot again about the hardware costs, but there's another cost when it comes to compliance that I think people should also be considering as they're tackling these edge applications.
There is, and while there's always change at the edge, certainly we will all feel that it's a particularly it's a time of great change around the world, here in America and around the world. And so our third prediction for 2026 is that there'll be these increased compliance costs and a greater degree of benefit from partnering with companies like OnLogic and Intel that navigate this for customers all the time. At Intel, we recently introduced an assured supply chain program for some of our existing products and our major products going forward. For customers who need to know the provenance of the silicon that they're getting, they need to know which countries, fab those products, where they're assembled, where they're tested, and we are starting to build that into every processor so that there are tools from Intel that can read that off the processor and tell you exactly where it went in the world. And that's useful for a wide variety of things, right? For disaster recovery, you need to make sure that you have some diversity of location of supply chain. For environmental reasons, there's a variety of reasons why you'd want to know. And these are just some of the new complexities that are in the world today that are really important at the edge going into 2026 that, a few years ago, people didn't think about that much.
Absolutely. And I can tell you, OnLogic, we've had, personnel in Asia for, well over a decade at this point. And it was specifically to really make sure, again, from a security supply chain, who are you working with? And it's extremely important to have those relationships over there. But also here in the United States, we have manufacturing in region. So the idea of kind of, the Build America and Buy America Act, we're very well positioned to be able to meet that, coupled with, again, our in-region manufacturing here, plus our deep relationships with some of those critical sources overseas as well. But the reality is that is not a simple challenge to solve at all. And making sure you have partnered with an organization that knows the complexities and also can keep pace with the change. I feel like, over the last few years, every year it's something different, and I don't expect that to slow down. So you need to make sure you're working with someone that is keeping up and is competent in this regard.
Absolutely. And, there's a constant set of change in that regard. There's also some things that are consistent, things like the requirements around manageability, right? The cost of a truck roll at the edge is cost prohibitive sometimes. And so you need to know that you can remote reset a machine, that you can go in and handle problems that may occur, that the hardware is going to be reliable, as we talked about, for a long period of time. And so we build in, vPro as well as standard manageability into our processors, and we work with partners like OnLogic to make sure that our customers can easily manage their solutions once they have them deployed. So it's not only about the sourcing and the complexity of the regulatory environment, but it's making sure you know how data is going to be managed, that it's not going to end up where it shouldn't, and that you have an ability to manage those devices at scale in deployment.
Absolutely. And I mean, all this adds up to, for, folks looking to tackle, an edge deployment from a considerations perspective, right? We spend a fair amount of time just talking about the hardware. Now we're talking about compliance. And so when people come with a list of must-haves, unfortunately, we're going to run into situations where there are like hard requirements where you will be, as a vendor, disqualified. If you don't meet, the Build America, Buy America Act as an example. This is stuff that's becoming increasingly more important, and depending on the project, an absolutely hard requirement.
It sure is. And so, to your point, having partners that can help you navigate that space is critical. This POC, proof of concept to production chasm, is one that I mentioned earlier, but is really where people get stuck the most. It's easy. It's not easy. That's too strong. It's easier to design something that works once when you can kind of throw everything at it. And it's really getting to scale that is the hard part. And it's these little things that trip you up, because there are requirements from different parts of the organization that really matter to the success of the business, that people often don't think through until near the end of the project, which really goes to, as you're scoping a project, for especially around edge AI, you're trying to get value out of it quickly, thinking through earlier, kind of a shift earlier in time approach to how would we deploy this if we wanted to, so that you almost start designing that into the solution up front. And then there's less of this. I've seen sometimes you get where, okay, we did the POC, now we want to deploy it. We basically have to start all over, building it all over again to get to something that's deployable. And that adds time and cost, versus if you start thinking a little bit about those deployment requirements up front, what is the cost structure need to be? To what degree is this going into a brownfield environment? Are we integrating in with an industrial PC or something that's already in place? What other existing applications and solutions are already deployed that need to be compatible? If you think about that a little bit upfront, I find it goes a long way. Maybe you see that with customers as well, to not having to start all over when you try and deploy it.
It's interesting, Matthew. You make me think about situations where we've had customers come in, and again, to your point, they've done their proof of concept, right? And they've kind of said, okay, cool, here are requirements and here's our budget based off of what we did at our proof of concept. And they come in, and the reality is they've not accounted for the environment effectively. They've not accounted for long-term reliability, durability of the solution. And the reality is, as a trusted partner, I like to lean on the idea of, we won't compromise your solution, right? And so we've actually had customers, this has happened many times, that we said, no, we can't meet that, that is not the right approach, and we don't have a solution that's going to do that for you. They'll go and they'll come back a year later, where back to your point, they've had to start all over again because they cut some corners. They took their proof of concept more or less as is to a live environment and found that it was not sustainable. And they just made, again, back to the idea of total cost of ownership. They just dug themselves a hole. right? And so it's, we don't obviously never say, hey, we told you so, but like we're not surprised when we see that come back, because we've seen this enough to know what do you need for the long haul? What do you need for this to be successful into the future?
Yeah, I mean, and I'll go. It's not something we had exactly planned on talking about, but you mentioned I/O, and that's an
Yep.
interesting example where if you take a standard consumer grade, you know, box and you think about, oh, I'll just deploy this. It often is much more limited in the I/O it can handle, and the edge is full of different I/O standards that are not what you would expect. Sometimes they're very niche to certain kinds of hardware that you need to interconnect with, or data buses you need to get info from, and it can be really tricky. And so you have to think about expandability. You have to think about the flexibility of the I/O capabilities in your solution.
Absolutely. We've seen that, you think of like a USB dongle, right? Maybe you can think of like a USB to a RS-232 adapter or something akin to that, or even a, USB LTE modem. And to your point, from a reliability perspective, again, you just added a layer of complexity to your solution where you got to make sure everything lines up. In the reality, after a reboot or something else, some other hardware occurrence, it may not come back the way you were expecting to because of the conversion. And so, yeah, we've seen that
Yes.
many times.
And we're having to look out often ahead of time, a year or 2 years, to make sure there are software drivers for upcoming standards of I/O and things before they even get to a solution, because it has to work with our processors ahead of time. And so we're often, Intel does a lot of open source development out there with a lot of partners, in part to make sure that everything just works when it comes time to actually build that solution.
I can tell you on a personal level and a professional level, I value Intel highly for that.
Excellent, gentlemen. Well, I think we have covered your 3 key predictions for Edge AI. One, the shift to video language models, or VLMs. One, about a focus on total cost of ownership rather than just initial costs. And about the importance of working with trusted partners and how partners will become an essential part of what companies use to be successful in the coming year. We do have a couple of questions that came in from our audience, and I would like to encourage our listeners to give us more, because we've got some experts here who really could answer whatever you need to hear about today. So please do share your questions. Right now, is there anything you'd like to say, gentlemen, or should we just leap to the first one? Let's leap to the first one.
Yeah.
And let me also offer some information to our audience. There'll be handout materials that have these links in there, but here you can see some of the sources of additional information from both Intel and OnLogic. But let's get to our questions, shall we?
Sounds good. Thanks, Renee.
First one we have here is, you touched on it a little, but they would like some examples of where you have seen these individual themes already playing out in the real world. And where is the most potential for what you're talking about today being reality sooner rather than later?
I think those are actually 2 different questions. I think that some of these ROI considerations are playing out in healthcare with a variety of medical devices, for example, where they traditionally often have had a discrete accelerator built in for some of the imaging processing. But increasingly, we're working with partners and customers who are integrating everything right in and using an Intel Core Ultra processor for a better ROI of that solution. And so we're seeing that ROI message and TCO story come to bear. But I would say probably some of the most potential is in the robotics space that I talked about earlier, of all types of robotics, simply because they benefit a lot from these new models, these VLM and VLA models. And the computing available at the edge is now reaching a point where some of this heavier duty workloads can be done at the edge without going back up to a cloud. And so we're kind of reaching a tipping point in that regard. I think there'll be benefit across every industry, though. James, what are your thoughts?
Yeah, I mean, if we talk about, where we've seen these played out, I can tell you a number of years ago, it was almost 10 years ago now, where I had one of my customers who was specifically doing machine vision in a factory environment. And back to the idea of infrastructure, they would have loved to say, hey, shoot, we just love to get all this data back to our servers. That's going to be the quickest way to get this data crunched, but they didn't have the infrastructure to allow that to happen. So that led them to, again, an edge deployment before the edge was even called the edge. Because again, they just saw there was no effective way to send that information back, because again, they just didn't have the infrastructure to do that, and the cost to build that infrastructure out was more than just getting compute at the edge, and that's what they ultimately ended up doing. And again, that played out almost 10 years ago, and I think that is still very much true today.
You raise an interesting point. I see this term thrown around, hybrid AI. Maybe you've seen that. People refer to that as well. When I talk to customers, one pure technologist take on that would be hybrid AI is about splitting the AI work between the edge and the cloud. But I'm not sure customers always think about it that way. I think actually what they mean is they're sometimes stuck in the cloud and they're trying to get to the edge, and there's this transition time during which they're hybrid, but they have a lot of cost from trying to do it in the cloud, and to your point, send data back and forth, and maybe that was a way again to build a POC. Now in deployment, they're like, that's not very scalable, and so now they're trying to transition to do more at the edge, and there's almost a whole practice now around hybrid AI and transitioning from cloud to edge.
Very interesting. One of the things another person asked about is selling these kinds of solutions up towards leadership. So they're complicated and there's many different layers. So what would be some of your advice in terms of making sure that leadership understands what the investment entails and how best to sell it up?
I would, it goes back to our second prediction, which is really shifting the conversation to that total cost of ownership, right? Again, I would highly encourage everyone to start shifting away from that simple, this is our, out-of-pocket expense to get the computers we need, to shifting it to total cost of ownership. Like, what is the expected true cost for us to deploy this and support it over the next 10 years? And so I think shifting to that model, and accounting for all the variables you need to effectively populate that model is going to be extremely effective in selling this to leadership. But you have to go deeper. I think it's very short-sighted now for folks to just look at this is just a one-time hardware cost. That is a very old way of thinking. It's getting more involved, more complicated, and so your calculation needs to be more sophisticated as well.
I totally agree, and we've started. At times we'll work with some of our sales folks and some of our customers to build out almost a spreadsheet of the math on this, because you're right, there's the upfront cost, then there's the power bill over time, especially if you're trying to do a lot of heavy duty edge AI. The power savings from not having a discrete accelerator over 5 years or 10 years really adds up. It's actually far more than the cost difference of the hardware up front. And then if you think about things like mature hardware like OnLogic's that is durable and reliable and not having to go in and replace it every few years because it broke, that's another source of savings. And so there's a lot of that over time savings that is not obvious when you're making the one-time purchase. So there's the cost angle to sell to leadership. Then there's the value side, and that's worth a conversation too, because often you'll get to, and we've had conversations with some of our retail customers when they're deploying, say, a self-checkout system, they're actually measuring how long does the line get in the store? How much shorter is the line with this solution? How much faster can people check out? Therefore, how much does their satisfaction go up? And how big a shopping cart do they have, because they're not like, it's too much bother. And so at scale, in onesie twosie, that's hard to measure, but at scale in a retail establishment, you can actually start to measure that and have a point of view that says, if we can cut the order time, the purchase time, the checkout time by 25%, that's actually worth something to our revenue, not just to our cost. And so you can start to build for leadership both a cost model and a value creation model in these things. And I think those are the cases that make it all the way through to production. Do you agree?
Absolutely. Right. I mean, again, to your point, like in that case, you are now creating value, and what incremental revenue can you gain from that additional value? And that, again, to your point, now you're just totally changing the game, and that calculation becomes a lot more compelling with that variable accounted for.
Matthew, a question for you. Looking for some more detail on these video language models. People who are familiar with machine vision and know how those work and understand what it can do for them today. Talk about the difference or what AI brings to the table there and how they can make that leap in terms of what they know to what's possible in the AI realm.
Yeah, that's great. Yeah, machine vision has been in place for a long time, and where I guess I'm not here to say, so I'll just be very frank with everyone who's watching. I'm not here to say that every solution is going to be a VLM or VLA based model in the future. It's really key to understand where it benefits the most, and where traditional computer vision or machine learning work can continue to work really well. If you have a use case with a fairly well-defined image or anomaly that you're trying to detect or identify, then those traditional models can continue to work great, right? There are certain anomalies in manufacturing where you have a well-defined model, it's refined, it's accurate. Don't break it if it's not broke, don't fix it. Similarly, the basics of things like license plate detection are so mature in the industry and so accurate, you don't need a new technology approach. But where these models really help is where there's ambiguity in the video stream on what's going on. If you're trying to look at a aisle in a retail store and understand, is it time to refresh this aisle? Are things getting too messy on shelves? There's a bunch of things that are kind of judgment calls, and interestingly enough, these new models help with those judgment calls and can be more accurate than a traditional model that can just count the outlines of shapes, right? Because it has more contextual understanding. And so that's where I find the benefit really kicks in. It is a learning curve, and you kind of have to go through the evolution of machine learning to traditional computer vision to Gen AI. There's now a lot of resources online to do that, and a variety of tools. At Intel, OpenVINO was something we introduced in 2018 as a software framework for this. We have anomaly detection libraries. Anomalib is one that's an industry standard around manufacturing anomaly detection software, et cetera. And we're gradually evolving these into the Gen AI world. So it's not a whole different set of tools from Intel. It's the same software tools evolved and augmented to do those new tasks as well. But there's a variety of capabilities out there to do this. So no magic bullet to learning this new world, but understanding what tool for the right job, I think, is a key part of it, because you're not going to use the same tool for everything.
Makes sense. Another question we have is, how is Intel collaborating with partners like OnLogic to enable ultra-low latency video analytics and AI compression at the edge, especially for multi-camera industrial or robotics applications where bandwidth and determinism are critical?
I can talk about the workload, but James, I don't know if you also want to talk about sort of the I/O into an OnLogic box and the best sort of solution for this.
Yeah. So something that Intel has integrated in some of their Nexus time-sensitive networking, which allows for, again, operating in real time. It ends up being a prerequisite for some of those real-time operating systems. And so we are very cognizant of understanding what technologies Intel has available. So when we're designing a system, we account for those variables and those technologies to make it more conducive to those type of environments. So Intel's absolutely pushing the limits in terms of what's possible, and OnLogic's being very cognizant of making sure we're leveraging the right features from Intel into our designs.
Yeah, and I would add to that, we have additional software capabilities in our Open Edge platform. One is called DL Streamer, or Deep Learning Streamer, and it's specifically designed for video stream processing at very low latency, keeping as much in-memory buffers as possible, not spitting it out to disk and back out again, doing the decode as efficiently as possible, pairing up with the hardware decode capabilities in our Core and Core Ultra processors, and to get the maximum amount of stream flow going. One of the interesting things, I encourage people, if you're looking at just AI benchmarks, especially for the edge, don't look at just the AI workload. Also look at the full end-to-end workload that includes the video processing and decode, because what we find is Intel processors have a lot more media decode than some other products on the market. And so it's one thing to have really fast AI, but if you starve your AI processor because you can't decode the video fast enough, then the net effect is your processor actually can't handle the workload. And we've carefully designed our processors to be able to consistently handle at every stage of the pipeline, that processing. So we can handle a lot of video streams in, decode them, hand them off to do AI inferencing, do something with that work after you're done the inferencing, and then keep going in a continuous stream through that. And it's driven by the requirements of real-time video analytics, as the questioner was asking.
Another question we had, technological question about advances in compute capability at the edge. They say they usually tend to need advances in communications to go along with them. What kind of advances in communications do you see being necessary to keep up with edge computing applications?
I mean, I can start. Obviously, 5G is probably the most buzzword when it comes to edge computing that we're hearing a lot, right? The idea of that you can get significantly more bandwidth than what you find from 4G. You can also do your own private networking as well. So there's lots of different considerations to make when it comes to LT, right? Is that your primary means of communication? Is it a backup? It kind of goes back into kind of your strategy of what you're trying to do at the edge. A lot of times we've seen historically where LT has been kind of like our backup plan, so to speak, where if we do lose local connectivity, we have a fallback plan. But 5G allows that to be more useful from a full bandwidth perspective. But there's been discussions for a while about LoRa, but a lot of these other protocols are just lower bandwidth, and so I think it goes back to a bit of what Matthew was talking about, and that's really kind of optimizing what is it exactly you're trying to do, and making sure you're architecting a solution that is purpose built and does exactly what you want. But there's certainly a lot of technologies out there from a communications perspective.
I don't have anything to add, James. That was a good answer.
Excellent. Well, I got a 3-part question from somebody about designing systems and some of the specifics of that. The first part is, edge can sometimes mean not mains power connected. How will we navigate the power-hungry AI in edge when it's battery powered?
I'll take the first 2 parts of this 3-part, leave the third to you, Matthew. So the first part, I mean, again, it goes back to the optimization, right? Like at the end of the day, folks, there's a huge part of this. I think I'd say for the last 2 or 3 years, really, in the kind of early days of AI, that people just been throwing hardware. And again, I think we touched upon it a little bit earlier about high-powered GPUs, expensive GPUs, right? GPUs that are by themselves pulling upwards of 200 watts or more. And that was just kind of I don't say easy way, but yeah, it was easy to hey, everything everything and anything can run on this thing, right? And so I think as we think about deploying in mass, you really got to start pruning your modeling and getting a lot more optimized and right sized for your actual application for today and into the future, with the consideration that you're going to make improvements and optimizations further, right? I would certainly discourage just throw a bunch of hardware out there, because to the question here, it's not sustainable, especially if you're going to go and be, limited power source in a battery environment. Like, you can't, there's no practical way to run a 200, 300, 500 watt computer under load sustained. That will be extremely expensive and complex. So again, optimization is something that I would highly recommend. And again, I make another plug for Intel. Again, Intel's processors designed to allow for all that versatility in one package. And we've also worked with customers where we're able to limit TDP, so limit the overall power draw as well, right? So a lot of Intel processors have great flexibility to use, upwards of 65 watts, but you can bring that down to 45 watts or 15 watts and get some controls in there. But again, it goes back to the idea of optimizing, because if you're reducing that power draw, you're reducing your performance as well. And so you got to make sure you're playing around and getting that right optimization. But the good news is Intel's got the right designs, and we have access to the right tools to help optimize that for you in those power constrained environments. And the second piece is talking about heat. What practical steps can be taken for cooling solutions in industrial compact environments when we don't have the luxury of data center cooling. That is, again, not a new concept for us. It's one that we've been talking to customers about for years. And what I always like to talk about is really two ways you can go about it. One is you can purchase the hardware off the shelf that's designed for those environments. So OnLogic has solutions that are designed to operate down from -40 centigrade up to 70 degrees centigrade. So that is an option that, if your environment's going to be pretty hot and nasty, we have solutions that can thrive in that. The alternative is that you modify or you manipulate your environment, right? Where if that environment is, we can see -40 or 70, you get a piece of hardware that can withstand that, or you optimize your environment, whether you're adding cooling to bring that temperature down, or you're adding heating to bring that temperature up. So there's really two ways to go about that. In both cases, a lot of due diligence to monitor your environment. Something I would just add when it comes to, again, that compute, especially in a hot environment, right? So people always say, hey, it's a 50-degree environment, but then we're putting it inside of a cabinet, right? So that's something I like to talk about a lot, is once you put the computer inside the cabinet, it's no longer the 50-degree ambient outside of the box. It's actually the environment that you're installing the computer is your actual environment. So you need to know what's going on there. And so monitoring that environment, what's that temperature actually inside the cabinet, that is now the operating environment for that computer. And paying attention to what's happening is extremely important, because now that computer itself is contributing to that temperature, right? And seeing how that behaves is extremely important consideration when you're doing these designs. And then Matthew, I'll let you take number 3 there.
Yeah, and this will be our last question of the day here. So this one was about, and we did have another one come in, so this won't be the last question, but let me ask you this anyway. What are Intel's plans when it comes to dedicated AI acceleration, and how does that compare to NVIDIA and AMD in terms of TOPS and efficiency?
Yeah, that's a great question. It's a question I get a lot from customers. We do have our discrete accelerators, our B50 and B60 discrete GPUs, but the heart of Intel's AI inferencing strategy at the edge is really focused around integrated AI acceleration. And our latest processors, the Core Ultra processors that you've probably read in the news, our upcoming Panther Lake product, have nearly 200 TOPS of AI performance. And so they are able to do the work of certainly any few $100 discrete GPU. You could just do that with a Panther Lake at 45 watts and get the work done that way. But I would also highlight that TOPS is not the only measure of AI performance. This new class of AI model, these generative AI and VLM models that we talked about earlier, are much more memory bandwidth sensitive. They don't only rely on amount of compute, they rely on memory bandwidth. And they're also very sensitive to the optimization and maturity of the software stack. And so at Intel, we have spent a lot of work making sure you get enough memory bandwidth to the integrated AI in the processor. And our OpenVINO stack is one of the most mature in the industry and was designed for the edge. And we believe is very mature. It handles over 900 models, including most of the new models coming out, as well as traditional computer vision models. And so we believe that our products can compete very effectively against other discrete offerings. And we do that via both an integrated GPU as well as an NPU built in. And those have different use cases, but they're both available as AI compute to the overall processor.
Great. This question is about how does Intel and OnLogic collaborate with ISVs and software partners to deliver more complete turnkey edge AI and industrial solutions? So what can you say both to the ISVs who might be listening and also to the end customers who might be using those ISVs about how you support those packages?
I can take a swing at that. OnLogic's evolved quite a bit over the years to be more cognizant of folks not just coming to us for a box, but coming to us, helping them solve increasingly complex solutions that they're trying to bring to market. And so we've built a pretty extensive partner network, and Intel is one of those key partners, where we are very much there to understand what our customers are trying to do and understand what I like to say what layers of their solution are they trying to attach. We have a few key partners in the remote management space already. We do have some in AI video analytics, and we're growing that relationship, but it really starts with understanding what our customer trying to do, what gaps are they trying to solve. Then we start identifying which of our partner network can help address some of those, or maybe they don't know, but they can also extend their partnership network as well. So it ends up being one of those things where we like to get in it with our customers. We like to understand what they're trying to do, and we like to bring in our partners to see how we can best solve that. So from into 2026, I'd say that is something that is going to be very critical for every hardware company to do. Is you can't just be a box provider. You got to be able to add more value to the conversation, and Intel's been there with us since day one in that regard.
Yeah, I would add to that. We have a relatively new initiative called Intel AI Edge Systems, which is we've been working with, OnLogic is one of our key partners around that to try and standardize the amount of AI performance you can count on from a system with validation from hardware partners like OnLogic. Because one of the problem statements we get is, okay, a chip can theoretically do X, Y, and Z, but how do I know if I've got validated operating system and drivers and software stack and components and BIOS settings? And how do I know I've got everything configured to actually deliver the promised performance? And so, with partners like OnLogic, we've been working to basically pre-validate all of that together, so that with OnLogic, we can go to ISVs and others and say, if you buy this solution, you can be assured it can run your performance at the level that you need, versus sort of buy and pray, or buy and have to test every configuration to find what actually delivers what you want. So that's a problem statement we've really been working on, and we think we can, with OnLogic, make it even easier for our ISV partners to have reliable performance from the final solution that they get.
Excellent. Well, I want to be mindful of our time today, and it looks like we're just about out of it. So I would like to give you each the opportunity, if there's anything more you want to say about your predictions for Edge AI in 2026, and or what people can look for from your companies in 2026 that can help them get there.
Well, I would just say we're really excited about the promise of Edge AI. And it's something that we are investing at Intel a lot in, and we believe we have really compelling solutions with partners like OnLogic. OnLogic is one of our great friends in the industry, and we think it's going to be a really exciting 2026 as these new inflection points really take off. Thanks everyone. James, what are your final thoughts?
I would echo what you just mentioned, Matthew. I mean, that's very exciting for us. Obviously, being in this space before it was been called the edge, and seeing it is just continuously booming. And again, Matthew's point, we have a very strong partnership with Intel, and there's a lot of great technologies coming out from Intel that we're very excited about releasing here in the coming months and years. And so we're really excited about the new opportunities those will help bring and help solve challenges for our customers. We're in a great position to help everyone succeed.
Well, thank you, gentlemen, for sharing your insights and for providing us the chance to ask questions of you today. I really learned a lot, and I hope our audience did too. I want to let our listeners know that they will receive a link to this so they can listen to it on demand at any time. And you'll also, any questions we didn't get to will be answered via email. So you'll be in touch. There was also these links and other resources that both companies have to investigate this topic further. So on behalf of Automation.com, OnLogic, and Intel, I'd like to thank you for your attention. This concludes our presentation for today. Thank you, gentlemen.
Thank you, Renee.